Good evening, everybody. So we are starting again. We are going to start this final track of this conference. In this room, we are going to talk about the technology and manufacturing challenges. How do we go from a concept or a prototype to mass availability of the projects we are discussing today? In the other room, so room 1, you will find the YouTube link on the website. There is a track dedicated to the legal challenges, so certifications and related topics. So if you're interested in that topic, go to room 1. I am happy to present our colleague Dario Pennisi, who is responsible for hardware development in Arduino. Welcome, Dario.
Ciao, Alessandro. Hi, everyone.
Dario is here with us as an expert, we can really say that, of manufacturing. So you can ask questions to him about all your concerns regarding manufacturing and especially sourcing parts, which might be not easy as usual during these tough times. Dario.
Yep. All right. So shall we start with the questions, or may I go through a short presentation that I put together?
I think you can start with your presentation. That could serve as an icebreaker.
Mm-hmm.
And meanwhile, people are free to post their questions in the chat.
Oh, of course, yes. I think you have to stop sharing. Thank you. All right. So let's see. So first of all, a short summary of what's happening around. Maybe every one of you already figured out, but the impressive thing is that the virus has gathered the community around a common enemy. And this is impressive because there are a huge amount of projects, mainly for ventilators. And there is it's very hard to track them all. It's impressive because most of them share, let's say, a common ground in terms of the architecture and so on, but some of them have very interesting approaches, and most importantly, some of them really tackle the aspect of making sure that components are available everywhere and so on. So that's really key for this. The other important thing is that I mean, there is a need for a lot of other stuff other than ventilators. And some of these are oximeters, temperature sensors, position tracking, and stuff like that. I mean, let's not forget that before getting in intensive care, there are a lot of things that we can do. And it's really important that we think about how to handle that. So that is really the last resort. So, of course, one of the suggestions I feel to make to everyone which is willing to contribute is that, I mean, hospitals are lacking places in the intensive care, and at least in Italy, where, as you may all know, we had a very bad situation. Although things are recovering, we still have a lot of issues. And although it's always possible to try to create an hospital in 10 days, like in China and in Italy, it's not really the solution. So most likely people that is being affected is going to be treated at home. And so I would encourage everyone willing to do something to think about what can be done for people at home that is sick and can be treated, can be somehow followed remotely and things like that. Also, keep in mind that designing a ventilator might seem the nicest thing in the world, but that kind of equipment is very dangerous. It can kill people. So that stuff very likely needs to be certified, and medical staff should be somehow comfortable with that. So it means it must have sort of, a medical proven interface. Also, it's very important to have a look at what you can do, as I was mentioning before, getting to the last stages of this virus. And so it's really important, and probably a much larger scale problem, tracking contagion and checking symptoms in the very early stage. Now, there is a problem in terms of the kind of problems that of the kind of approaches that the two sides of technicians are taking. Medics, on one hand, know very well what to do, but they're lacking very likely engineering skills. They may go wrong on the kind of sensor selection or on the kind of motor or the power supply, the software development, and how to, let's say, make sure that all of this stuff that works together is reliable. At the same time, engineers very often read the specs and think they know everything, but they don't know what is really required from the medical perspective. And I have seen a lot of projects where basically people has designed things and then just at the end thought about looking at medical specifications for that kind of device. And of course, one of those big issues is the hardware failsafe. An engineer usually thinks about adding a lot of sensors, a lot of closed loop controls and stuff like that. But actually, we all know that things can break. And it's very important to have hardware failsafe, because as it was very clearly stated in the other session, basically, if you put too much pressure or reduce the pressure too much, you are going to kill the patient. And again, we are engineers. I am one of those that like to add as many features as possible, and we always end up overcomplicating everything. So let's keep it simple, stupid, right? Let's keep it, let's say, manufacturable, the least possible amount of parts, the most easy to source. I mean, think about the fact that there are places where very likely motor controllers, but even ambu bags are not easily available. And this kind of shortage will increase with the demand and with the fact that even logistics is a nightmare today. Couriers are not delivering anymore. And of course, one last thing is, everyone talks about Industry 4.0, connectivity and so on. Keep in mind that hospitals usually don't like having wireless. Wireless is not something that is considered reliable. And so, I mean, if you have to connect your stuff, think about wired possibly, and think about the fact that every data that you take out of a medical machine is sensible data. And there are, at least in Europe, very strong laws preventing this information to be distributed. Now, the very interesting thing is that in these days, there have been a number of initiatives which shared links for complete designs or requirements for ventilators. And this is very interesting because the first link is probably the most interesting, because that is the full design of a medical unit that has been approved and actually is in production. So it is very important to have a look at that, because that really brings a lot of information. The other interesting thing is the UK government actually shared a very detailed say specification list for what is required and what is optional. So that is really something you should have a look at. And finally, there's a lot of, let's say, projects which are doing a very good work in sharing their roadmaps, their documentation, and so on. And I encourage you to have a look at those. So the bottom line is our community is made of makers, and we love to do stuff ourselves. But when we talk about medical equipment, we have to think about three very important things. First one is redundancy and reliability. So first of all, this should not absolutely fail. If it fails, then there must be some safeguard, something that allows the hardware to, let's say, prevent the patient to be harmed. And of course, if you have a sensor, probably you need at least 2 or 3 because something can break. Remember that ventilation means moving air in and out probably 1 time a second, or I mean, 1 time every 2 seconds. So there is a lot of stress on every mechanical part, and this should be up there for quite a lot of time. Also, it must be solid. I mean, as makers, we are usually happy when we have a lot of wires hooked up and somehow have it working. But in this case, there is a very important aspect, which is this equipment, especially if it's going to be in an hospital to treat a patient which is in critical conditions, must be easy to clean, must sustain liquid splashes, and by liquid splashes, it can be anything. I mean, it can be vomit, it can be blood. I mean, we're talking about people that is really sick. And then approvals. I mean, it's very important that if you start something, you already have on your roadmap clinical trials on animals and humans, and you know how to handle that. Because, I mean, if you're not getting there, don't even start. There are a lot of other things that you can do that are needed and which are very useful. So let's try to keep the efforts concentrated on the few things that really are working. So in terms of manufacturing in volumes, let's say that you planned everything, you designed everything, and now you want to manufacture. There are a few things that you have to take into account from day zero. The first one is design for manufacturing. What this means is that you have to, first of all, make sure that the components you select are available and will be available from the supply chain that you're selecting and that you have at end. This is not really trivial because if you just look at distributors without talking to anyone, you may not know that some components are going to be end of life, for example, or that they are just available as a limited stock after which you have 14, 16, 20, 50 weeks of lead time. So it's very important that you talk either with the silicon vendor or with the distribution to make sure that those components are and will be available during the production lifetime. Secondly is the manufacturability. Very often designs are full of connectors, harnesses, and many different parts. So this means that the manufacturing the system, not just a board, will become very complex, and it will take a lot of time and will make also the whole product probably a bit more critical. So a review on the design, on the basis of the design, is really, really important. And finally, you have to make sure that testing, production testing, is also not an afterthought. If you deliver something, you want this to be working, and you have to make sure that, I mean, every unit has the same features of the one that you validated. So not only you have to test as much as possible, but you have to make sure that the coverage is high enough to make sure that every device that you ship is compliant. And then finally, when you completed the testing, then you have to make sure that, first of all, all of your devices are, let's say, all of the components required to assemble the devices are available through your supply chain, and the delivery is working, because I mean, you can manufacture a lot of stuff, but then you have to deliver. And this means making sure that the couriers will bring goods in time where it's needed. Keep in mind that there are areas which are under lockdown, and so you may need to have special agreements with governments and with couriers to deliver in particular areas, especially the ones that are most affected. And finally, I mean, since shit happens, everyone knows about it. Even if you tested it very well, something may go wrong, or the user may have trouble operating your device. So you have to make sure that you have means to support your users. Again, we are talking about thousands of infections, and thousands of ventilators, and maybe hundreds of thousands of people ill. So we have to make sure that there is a structure behind whatever you are designing that is going to be able to support whoever is using that. So what we are doing in Arduino is, first of all, well, we opened immediately a page under the Arduino website, COVID-19, where you can get information about what we're doing, what is our level of operation, and about the events like this. And we also added a very important link, which is Contact Us, where basically we are asking you to contact us directly if you have a critical project for which you need a large supply of boards, so that we can make sure that you get what you need. Of course, if you see stock around, you can order that. But if you talk to us directly, we can make sure that, first of all, that the quantities you need are stocked for you. And if those are not in stock, we can get you the lead times. And also, we can provide you personalized quotes based on volumes. So we understand that, of course, our prices are based on single pieces, at least on the stores. So if you're talking about tens of thousands of pieces, then of course we are very willing to help you. And finally, not least important, I am committed to providing hardware and firmware design support to whoever is something relevant. So feel free to contact us either through the forum or through the forum we have on the Arduino website, or via Discord, or whatever means you wanna, and you wanna reach out, and we'll be happy to support you as much as possible. So finally, I'll try to show you a small comparison, because most of the designs that we have seen so far are more or less based on the same products. So right now, the products which are mostly used are the nanos, because they are really low cost, and they provide more or less whatever is needed for small PLCs, which is more or less whatever is needed for a ventilator, a simple ventilator. So let's say nanos, unos, and mega are the most used ones. Mega probably is the one that has been more, let's say, interesting for the more complex devices, where people is using multiple motors or multiple sensors. So of course, this the design, the board you choose is basically heavily depending on the complexity of your design. And although we are not yet shipping it in volumes, we are also advising some people for advanced designs to use Portenta, which is our latest brainchild, which is designed for, let's say, more complex applications. It has high-res graphics with DisplayPort and so on. So on that one, of course, we are not recommending it to everyone, for the simple reason that is quite different from the usual Arduino designs you're using. But I mean, if you think you have the need for that, and especially if you are planning to use something like a complex user interface and so on, maybe this is for you, because that will help you in designing something which is robust, industrial temperature, and will last for quite a lot of time in very extreme temperatures as well. All right, so that's more or less it. So I hope I didn't take too much time, and I'm waiting for your questions.
Dario, you will not wait too long, because we already got a number of questions during your presentation. So,
Okay.
Robert Reid, who was one of the speakers who introduced this conference, is interested in what you said about not using Wi-Fi. He's asking, what are the issues with wireless, and can we count on Cat5 Ethernet instead?
Well, actually, I'm not an expert on medical environments, but it is my understanding that it's preferable not to have any source of radio frequency close to other medical devices. Even if, I mean, you know that this kind of stuff is somehow, let's say, certified not to be affected by that. That is, of course, something you have to take into account. The other important thing is that wireless is not that reliable. I mean, anything can happen. Someone can come up with a high energy RF source, which is disturbing the communication, and you don't really want to be affected by that. Unfortunately, the Wi-Fi uses a free part of the spectrum, so anyone can transmit there, and it's very easy, unless you have a very strong infrastructure, to be jammed by other transmissions. So, of course, Ethernet is much more robust because it is absolutely under control. And other than that, I mean, there are a lot of applications which are still using serial ports or other wired communication.
Mm-hmm. There is another question by Robert, which probably tackles the main concept building these projects. Are some Arduinos in greater supply than others?
Well, that's a very good question. We are trying to prioritize the requests, and the last slide I showed is basically already sort of an answer. So we are prioritizing the nanos, which are more or less the most requested, the unos, and the mega. Those are the ones that have been mostly used in, let's say, 80% of the designs that use Arduino. There are some other fancy things, but we are trying to steer everyone on the same boards so that we can limit the kinds of boards that we manufacture. At the moment, we are not seeing capacity problems, but of course we need to have some planning. So whoever has a real project and it's somehow willing to go in production soon, we can plan it in advance.
Yeah, there is well, there is still some discussion about the connectivity topic. Robert is asking, will clinics have wired Ethernet?
Actually, we do have some Ethernet shields for Uno and Mega, and we have Ethernet on top of Portenta.
So these are the boards supporting Ethernet.
Yes.
Yeah, the product recommended for Ethernet connectivity. I would like, well, while other questions are flowing, I would like to while we collect the questions, I would like to ask you, I know you attended the previous track about ventilators, about
Yep.
Arduino-based ventilators. I would like to ask you, what are your impressions after hearing that long list of efforts by the community in terms of technological challenges? What still need to do, and what level of maturity did you see?
Well, actually, there's really a lot of designs, and we have seen some of them being pretty mature. Some of them are already in experimentation on animals, and soon will be on people. So I have very high hopes that very soon, at least some of these designs will get used in real life. As I was mentioning, the most important thing is that let's say these designs have been thought of with different goals in mind. Some of them are using very common parts, and that's very interesting because those can be easily replicable. I think that one of the issues with that kind of concept is that if you do an open design that then can be assembled by anyone, I think the issue there is that you may end up having no one manufacturing it. I mean, if you have this community creating something, then probably you have to also make sure that that community has people around the world which is ready to manufacture that following a very strict procedure. So let's not just keep this, let's say, 1 inch from the end. Let's try to think about the whole process. And that's my message to everyone which is designing something, not just the ventilators, because as I was mentioning, there are very big pitfalls waiting for you on manufacturing, on logistics, and so on. And I think it's really, really important because it's very easy to fail here. I mean, for example, we have shipped boards from Turin, from Biella to Turin. The distance is 40 minutes by car, and it took 10 days because the courier was not actually able to deliver them because they were overwhelmed. So that's exactly my point when I was talking about the supply chain and the delivery. It's really critical right now.
Dario, so far we talked about the very hardware part and manufacturing. What are your thoughts about also the safety issues? Speaking of software, I mean, is there any good practice you would recommend in terms of, for example, decoupling the logic of these devices, splitting interface from core functionality, in terms of best practices we can tell to our community?
Yeah, actually, there's one big thing that let's say works very well with newcomers to the programming world in Arduino, which doesn't work very well in some of these applications, which is the loop thing. So basically, the Arduino software structure is mainly a setup and a loop, where basically you are supposed to have a big state machine doing things. In reality, there are libraries that allow you to do sort of multitasking, and those are, let's say, the things that make things a bit more complex, because basically, usually you want to have on the same board the logic that drives, let's say, the application, and then some logic that displays the user interface or that handles the input and so on. So in that case, it's a bit tricky if you don't handle things correctly, because you may end up screwing up the core logic if you spend too much time, for example, updating the user interface. So that is really something that needs some attention and some good profiling. And at the same time, it's also one of the reasons why, let's say, we thought about Portenta, which is a dual core where you can have two separate processors doing two completely different things. So you can have Python running on one side and Arduino running on the other. So with Arduino, you do the low level, and with Python, you may do, for example, the user interface.
These are advanced hints for developers, but since we are talking about critical devices, they are not never advanced enough.
No, I mean, the real problem here is, as I was mentioning, also redundancy. So, for example, a good design might be to have several boards, not just, let's say, processing boards, but also sensors, and make sure that you read all of them and have tribal voting. So, for example, if you need to measure pressure and one of the pressure sensors may break, then you have to have three and say get the most likely value out of the three. The same happens for the mechanics and for the electronics. You may want to have two different boards, one driving the application and one driving the user interface, unless you have a dual core processor like this.
And what about power supply? How critical is that part? Is there a risk of not putting enough attention on that topic?
Yeah, one of the lessons that I learned while trying to support some of these designs is that it's a bit hard to understand how much force you need to compress the ambu bag, or I mean to send air into the lungs of a patient. And because basically the amount of resistance you get varies quite a lot depending on the patient. So the amount of power that you have to give to the motor is very high. And I've seen projects where they started with a small motor and with a servo actually, and then they migrated to very big stepper motors or let's say linear actuators. So let's say that first of all, over designing in this case is a very good practice. And you may want to have, of course, a very big motor driver and a very big motor so that it can sustain full day operation. I mean, this is something that should work 24 hours a day with the motor, which is almost working every time for the full time in both directions. So there's, I mean, a lot of reliability issues there. And of course, the power supply must be able to sustain this. Don't just assume that it's good enough, measure it. I mean, if you think that you have something which is close to the limit, measure the power supply because it may dip and may cause unwanted results.
Right. I think we will get back to the power supply topic because I see some debate in the chat. But I also wanted to ask you about the MKR boards, since
Yep.
some people are asking about them, and since I see quite a bit of interest about connectivity. The connectivity topic is raising doubt. So
yeah, it is my fault actually. I should have mentioned it. So of course, among those boards, we also have Maker Zero, which is also very interesting. So it's somehow a basic board which has a Cortex M0, the same that's on the Nano IoT. And the interesting thing about the Maker is that the family allows you to change to swap the board, having a different kind of boards with Wi-Fi, Bluetooth. Depending on what you are looking for, you can get the board of your needs. And of course, over that one, we also have shields for Ethernet, for CAN, RS485, temperature sensors, thermocouples, whatever.
Yeah. Well, meanwhile, I see that Sherman Chen is commenting on your thoughts about redundancy, and especially mentioning the Portenta, which is one of the values of the Portenta is in having the possibility of this kind of redundancy between the different cores. So this is something that well, looks interesting for our
Let me
audience.
also add that the other interesting thing about Portenta is that it also has two kinds of crypto chips. So if you really want to send data to the cloud and you're allowed to, you can use very strong security by storing certificates and keys into these secure elements.
Right.
One of the two.
While you were not in this room and during the previous track, we were talking about pulse oximeters and collecting data from pulse oximeters to the cloud, especially to monitor elder people remotely. And people were commenting about security of this data transfer.
Yeah, absolutely. That is there's a huge issue. I mean, of course, you can think that storing a password in your code is robust enough if you protect your code in the microcontroller, but actually that's not the case. Unfortunately, you have to think about the fact that the world is more and more connected, and thinking about the fact that this data might seem useless is just a mistake, because there's always going to be someone looking for some additional data for improper usage, and that will affect you. So think about security even before you start thinking about IoT.
Right. We have there's a question about Portenta. Is the Portenta USB power delivery compatible?
Yes, it is. We support power delivery. However, keep in mind that Portenta is 5 volts only. So what it does is it negotiates the amount of current it requires, but it doesn't use power delivery to, let's say, let the source generate higher voltages. We are also able to source power from Portenta if needed, also because Portenta has DisplayPort output. So one of the applications we have is connecting USB-C to a hub with DisplayPort output or HDMI output, along with USB hub and things like that. So that really becomes like a laptop that you can connect with a keyboard, a mouse, and a traditional display.
Oh yeah. No, there is a very technical question, but I'm not sure. We can pretend you have a complete answer, but what protocols do medical devices typically use? What logic levels are typically used?
Okay. I don't think I have those kind of answers. What I know is that there is an open standard for data exchange, which is called DCOM. And I have been designing some stuff based on that. I only know partial it. So I don't really have an answer. But if you look for DICOM, you can check there, and there is at least some data about how data is exchanged between medical devices. I'm not really sure how data is eventually exchanged between devices in terms of control. I have no idea.
Right. So other people were discussing the redundancy and the decoupling topic, and there was this very technical questions, but interesting for developers. Is it recommended to apply FSM rather than schedulers to trigger tasks in Arduino Uno and Mega? Maybe if we can provide some context about this question, because I'm not sure that everyone understands this.
Absolutely. So the question is, assuming you have an Arduino, as I was mentioning earlier, you have a loop function which is called regularly. So the first thing to remember is that it is called regularly if you exit regularly from the loop function. So for example, if you use a blocking function such as, for example, moving a stepper motor, then remember that, I mean, you cannot do anything else while the motor is stepping. And the same applies for other blocking operations operations, such as driving a NeoPixel or things like that. So it's really important when you have a state machine that you time exactly what is happening, and you take into account for errors. Because, for example, if you have an I2C cable and you have an I2C device, you have a long cable and there is some noise or something, then the device might reply with a not acknowledge, which means that you have to retry the operation, for example. So instead of staying into that operation for a short while, you may stay there more than expected, and you have to take that into account. So you have to have timeouts, you have to have now a number of countermeasures to make sure that the maximum amount of time you spend into each step is properly measured. On the other side, if you go for multitasking with a scheduler, there are two different ways of doing that. With a cooperative scheduler, you are able to switch tasks when you give control to the scheduler. So again, things are not ever happening in parallel for real. They are happening only when you are, let's say, not doing something useful, so you're giving control to something else. And there is real multitasking, which we are able to support on some of the new nanos, which run embed and on Portenta, of course. But that also poses a number of other issues, because multitasking means that the same processor executes different things sequentially, but you think they are happening in parallel. So you have to take into account that while you're doing something, you might be interrupted and resumed slightly later. So, for example, you cannot pretend that timings are really, really precise if you're using multitasking. And that's one of the reasons why we started Portenta, which has two processors. So if you really want to have something very timing, let's say, with very precise timings, then you can run it on a dedicated processor. That's really the whole point.
Right. All right. I would like to pick up this question that was asked, not about electronics, but still it's a technological challenge related to COVID-19 projects. What is your opinion on designs that use many 3D printed parts? 3D printing is fairly slow. Would it be too slow for mass production of large quantities? I would like to give my opinion, but also to hear yours, Dario.
You are the 3D printer wizard, so probably you should answer that. But I can give you my opinion, which is probably totally wrong. First of all, never underestimate the community. Actually, I think that there has been a lot of discussion about those 3D printed adapters for the face masks from Decathlon and other makers, other manufacturers. And basically, in Italy, the organization that designed them asked the Fab Labs to ship over printed parts, and actually that happened. So, I mean, 3D printing may be slow, but don't underestimate the power of the community. My concern about that is really a bit different. It may happen that, for example, you may have faulty parts due to the fact that some 3D printers have less precision, and the layers may not stick very well. So the part might not be, let's say, replicable too much, and may not be able to sustain the pressures and the mechanical stress that is involved with these kind of devices.
I totally agree with your point. Basically, the effort in designing and refining a project should be in reducing the amount of 3D printing material, for example, by using readily available parts, for example, fasteners, for example, laser cut plywood, or other kind of plastics, or other kind of materials that can be manufactured or sourced more easily. So it's a compromise. However, as you said, the power of the community and the distributed manufacturing is demonstrating that there is a lot of potential manufacturing capability that is being exploited. For example, in Spain, there are local communities organized in using local Telegram chats so that they can spread the requests to the local chapter who is able to manufacture locally. And this is something that can be really exploited if there is a good reason for this. So going back to electronics and software. I think we have seen during this conference that a number of communities are developing projects putting a lot of attention on the mechanical part. However, you also in your presentation you mentioned how they should work on the safety of the device, also from the software point of view. But I think it's not enough to tell them take care of that part, because I think all those people are doing their best. Is there something we can, some hint, some good practice we can tell to these community projects so that they increase the level of maturity of their projects, even if they don't have the resources, the skills within their team?
I guess that here the point is probably the reason why we started this conference. I was really surprised to see so many designs that look so similar but are so different. And of course, it's very important to have differentiation, because you may invent something maybe if you work by yourself for a while. But the power of working together is really what makes the difference. And if I look at the projects that are around today, some of them have hundreds of contributors. And that's really where things start to fly, because of course, you may be naive on a topic, but you may be an expert on something else. And when you start discussing topics with other people that have different experiences, then you create a knowledge which is bigger than the sum of the knowledges of the participants. And in particular, I think that the amount of knowledge required for such a device is really huge. And for example, looking at the specifications that you get from the UK government, you get a glimpse of what's needed. But if you look at the design from Medtronic, that is really key. I mean, it's really, really interesting, because they are mapping the requirements of the software and the hardware to specific medical requirements and directives. So you not only know that something is needed, but also why. And I mean, as in any cases, I mean, you need to study a lot. Don't pretend that you're the smartest guy in the room. I mean, you have to look for knowledge for everything that you don't know enough about. So consult with medics. if it's a medical device, consult with medics. Read the documentation and make sure you understand that. That's really the point. And consult with a lot of people.
Right. Very, very important hint. We have a technical question. Do you have proper recommendations to shield the boards against EMI?
Wow, that's that's difficult. All right, so if you want to avoid EMIs, first of all, you shouldn't need to shield the board. The first thing you need to do is design the board so that it doesn't emit that, and that is really, really difficult. First of all, it really depends on many different aspects. For example, if you are designing a board which has high-speed clocks, then very likely power supplies are going to be the main source of EMI, because I mean, you have the clock, which of course is critical, but usually that is a very short trace and doesn't have any problem. But what happens is that inside the chip, everything is running at that speed. So the current that goes into the power supply is actually oscillating slightly at that frequency. So that's really where the problems are. So you have to design your power decoupling very carefully, and you have to make sure that there is really no ripple. I mean, if you see ripple on the power supply, that means that you're actually very likely emitting EMI. In addition to that, connectors, cables, those are the places where signals take off in the air. So basically on every interface, you have to put, of course, ESD protections, which are needed to avoid frying the board when someone, let's say, touches the board with a charge on it. And of course, you need to have high-speed inductors to prevent internal frequencies to be transmitted over the cables. And then, I mean, if you really did everything right, but you still are emitting, there are different ways to shield the board. There are conductive paintings that you can spray within the box. This is a very expensive solution, but works very well for artisanal products. And otherwise, try to use as much as possible metal boxes, metal shields, and so on.
Well, this was an important topic. Yes, and the person who asked the question is saying that appreciated your answer.
Thanks for the question.
I would like to invite the speakers of the panels who are attending this one to comment or to share their thoughts, since they actually went through these challenges while making their prototypes. So if they have something to do, just raise your hand and we will bring you in the discussion. So you were mentioning in your presentation that Arduino is also available to support these communities with design help.
Yes.
And people are asking in the chat more information about what Arduino is doing on that front. So.
Well, first of all, I am personally discussing with some of the teams. Of course, it's going to be impossible for us to support everyone doing, let's say, every sort of hardware. So we are trying to somehow give the best possible answers through the forum, for example, and following up with the groups which have more medical relevance directly. So for some of them, we wrote some code. For some of them, we did some design reviews. For some others, we are just, let's say, helping them in, let's say, selecting sensors or sourcing boards and things like that. So, I mean, we are trying really to do whatever is necessary, whatever is required to help. We understand that, I mean, the biggest issue really is not, in my opinion, the design. As I was mentioning, the designing and making sure that the product work is probably half of the journey. The other half is, let's say, manufacturing it, testing it, and delivering it. So I think we are still in the early days, and everyone will see a lot of trouble in front of them. And I mean, we are also willing to help with the sourcing of the components if needed. Of course, again, we can't do everything for everyone, but if there is something relevant, we are very happy to help.
You mentioned testing, hardware testing, and I'm thinking that, well, we know that Arduino can be used for a very wide range of purposes, from learning, education to industrial grade applications or professional context. In between, there is a lot of a big variety of potential applications. I think that many people are actually moving from simpler applications to more professional applications using Arduino. So testing a prototype is a key part of making a reliable product. What suggestions can we give about properly testing an electronic product, which is it's a combination of an Arduino board and other components all together, and what is the correct approach to properly test this kind of product?
Well, first of all, I want to hijack your question, adding also the concept of validation, because there are two aspects of testing. The first one is validating the design, and the second one, of course, is testing during production. Very often you get problems in manufacturing because you didn't validate properly the design, and you didn't figure out that something can vary enough that the product goes out of spec, for example. So it's very important to make sure that when you start a design, you have a validation plan and you have a clear idea of what you need to test, what you need to measure, in order to make sure that what you are designing is really compliant with your expectations. As I was mentioning, sometimes, for example, I was mentioning it during my presentation, you may assume that something is working just because from the high level perspective it works. So you try to tell a motor to rotate and it rotates and you're happy, but then maybe you connect a load and it doesn't rotate anymore, or it get some dust and it becomes harder and harder to rotate and it doesn't work anymore. And maybe you're guaranteeing your system to work for 1 year in extreme conditions. So validation is really, really very, very important. And then testing is also very important, as you were mentioning, because you have to make sure that the manufacturing process allows you to replicate the same level of performance of your validated prototype. And this is a really key point. I mean, as Arduino, we have been famous for having very reliable boards, and that's something we are very proud of. We manufacture them in Italy, not because Italy is better than anyone else, but just because of the fact it's close and we have all the process under control. And in addition to that, we test our boards very thoroughly. I have a guy who's really getting crazy with this. And the interesting thing is that as many other people is doing, we are testing Arduino boards with Arduino boards. So we are putting together a test system, which at some point we plan to open source, which is going to be used not only for testing during manufacturing, but also for continuous integration. So this is an effort that we are, I think is a bit overdue, but we are working very hard on that because we want to make sure that the quality of our code improves. And we want to make sure that whenever someone contributes, the library is tested against all of the hardware it claims is compatible with.
So I was scrolling the chat since there are still some questions. There is a very practical question about power supply. Is there a good solution for unstable power supply from like a 12-volt car battery?
Okay, I don't think that a 12-volt car battery is unstable. Actually, it's probably one of the most stable things you can think about. What is really unstable is the voltage when you have the cranking. So when you turn on the engine, and that's because basically the engine requires a lot of current from the battery, and when the engine starts moving, the battery starts to get charged. And that, of course, creates all sorts of noises and spikes on the power supply. So, of course, if you are designing something which is supposed to be working during, let's say, cranking, then good luck. There's a lot of work there. But other than that, let's say, car batteries are huge, so they act like the biggest capacitors in the world. So, I mean, you shouldn't get any instability there.
Right. I think this kind of this person who asked this question says that they want to use a battery to solve the 110 volts power supply problems. So we need a circuit to charge the battery while using power.
Yeah, I mean, for that, you can actually buy off-the-shelf chargers. Usually, you can find some DC-DC converters, which are basically LED battery chargers, and at the same time, they also provide you with the power. Basically, they are sort of UPS systems. So they provide you with 12 volts, and these 12 volts are automatically switched between the battery and the power supply. The battery is continuously charged, of course, and there is also controls for overcharge, undercharge, and so on. So I would say just use those. They are sold almost everywhere on Amazon and so on. The problem is eventually sourcing them, but right now, but it is common components, I would say.
Mm-hmm. There is a question I'm not sure I fully understand, but no, okay, I see that Massimo already answered. Massimo Banzi already answered in the chat about availability or the need to manufacture these DC converters, which are actually available in the market. We are reaching the end of this track, but we are still here for a few minutes in case there are more questions about manufacturing, about sourcing parts, about how can Arduino support the communities fighting COVID-19 on the technology side. Yeah, the recording of this session as well as the entire conference will be available afterwards on our YouTube channel. Also, we will be reachable through also in our community channels. So if you go to Arduino forum, you will see there is a COVID-19 board dedicated to these topics. So the discussion continues there, and also in our Discord channel dedicated to the pandemic response by the community.
Let me just answer that question about the sourcing. So, of course, it's going to be very difficult for us to support smaller communities. We are always there to respond to forum requests and so on. The real problem with sourcing components right now is that you have to take into account the fact that either you have really relevant, or basically you have to think about the fact that there is someone which is trying to, let's say, solve very big issues and needs prioritization. So, for example, in Italy, we had a lockdown which forced all of the companies which are not strictly related to the medical supply chain to stop, basically. So, I mean, you may say that this is unfair because your project is the most beautiful in the world, but you have to think about the fact that, I mean, it's really difficult. As I was mentioning, couriers are having trouble delivering everything. And Amazon, for example, started stopping the delivery of some kinds of goods because they want to make sure that who really needs something gets it. In any case, if some relevant projects needs help in sourcing parts, we are really close to silicon vendors, and we are happy to make connections to make sure that you design in the right parts and you get them when it's needed. As I was mentioning, we have this form. Please fill it in, get in contact with us, and we'll make sure that we address your questions as fast as possible.
Dario, we are collecting the final questions. I wanted to share with you a thought I have seeing what the community is doing as a response to the COVID-19 pandemics. I see that many people are using the well-known Arduino boards for their projects because everybody knows and loves the Arduino Uno and the well-known Arduino Nano. However, for many applications, as you mentioned in your presentation, there are boards that are probably better suited for these applications. I mean, the Arduino families are much more
bigger, yeah,
big exactly than the Arduino Uno and the Arduino Nano. So I would really like to invite everyone to go to the website and see all the ones you mentioned in your presentation. So the new Nanos, the MKR boards, which are several boards with different connectivity offering, the Portenta, and all the families, and actually reach out to us and ask whether anything is not clear, because there might be better options for your projects than the default choice.
Yeah, let me add something very interesting. I mean, of course, everyone loves the what we call the hero products, Uno, Due, Mega, Nano, and so on. However, we really worked hard to evolve and to give our users a better experience, more features, and so on. And the one thing that is really outstanding is that you can run almost all of the libraries on almost all of the boards. And that's really important, because most of the times, whatever code you wrote on a board can seamlessly run on anyone else. And that's really important, because if you run out of pins or if you run out of resources, there's always another bigger board that can suit your needs. So, I mean, I gave you a list of boards that can be used as preferential, because we are prioritizing them in this period of difficulty for the logistics. But if you look at our catalog, we have really a huge amount of products for every possible application. So I really advise you to check it out.
There is an important question. Will the Arduino factory be open to keep up with demand? Because we know that many manufacturers of boards are not able to ship. There is a bit of uncertainty about supply chains. Maybe it's important to stress what Arduino is doing in terms of supplying and keeping up with the demand.
Yeah, absolutely. And I mean, we are collecting, and if you have more information about that, please do that. We are collecting letters from the various groups that are doing important things with us, also to demonstrate our government that in a way we are essential for the development of this equipment. So they are with us. They know that we have been doing a very good job in supporting people. And so basically we have a particular status in Italy which allows us in our supply chain to stay open regardless of the various decrees that are stopping everything else. Now, of course, we are trying to do that for a limited number of products. So you may see shortage on some of the products that I didn't mention, for the simple reason that, of course, we have stock. We are still manufacturing something. However, we are trying to give priority to all of those products that are in higher demand for critical designs. So I'm not expecting to have huge trouble, because our production capacity is quite high. But there might be, of course, some delays if things, of course, continue like this.
And if you go to our website, there is a COVID-19 page, which is up to date. We keep updating it every day. So you will see the current situation of the distribution network of Arduino, the resellers, and our direct contacts. So if you are in the need of, as Dario said, of a large quantity, especially for medical reasons, you can reach out to us, because we can help you understand how to source these parts in the most reliable and the quickest way. So I think we are we are done. I don't see any more questions. Well, so I still invite you to come to our community channel, the forum, and Discord to share your thoughts. And thank you a lot, Dario.
Thank you.
Your presence was very well appreciated by our attendees. We should do this quite more often. So thank you to everyone. And let's continue talking, because the emergency response needs makers, needs engineers, needs open source hardware and software, and needs our collaboration. So this conference was our contribution to this worldwide collaboration. Thank you, everybody.
Thank you.